All right, cool. So first, announcements, fall RVB. Clements, you want to talk about it?
Hello. So as you might have heard by now, we are hosting our fall RVB on November 12th from 11 a.m. to 5 p.m. Fall RVB is a great opportunity for you to come out and for you to practice your skills, to learn business, IT, and system administration skills, and to generally have a good time. We welcome everybody from all skill levels. So even if you're brand new to cyber, we encourage you to come and try it out. We have teams of 4. The sign up is right there, da.gd/fallrvb, or you can also find it on the link tree. I think that's pretty much it.
Thank you, Clements.
Hi guys, so we're going to be having a pumpkin patch social this Sunday. I know you guys have probably seen the pumpkin patch on campus, and we're going to all check it out together. So Swift is going to be there from 4 to 7:30. Tickets for students are $7 for general admission, and the wristbands are $14, bringing it to a total of $21 per person. If you guys want to go over and walk with us, we're going to meet at the spaceship building, and we're just going to head on over together. It looks really, really fun. The activities that we saw and are super, super hyped about are the petting zoo, the sunflower farm, the mazes, and of course the pumpkin patch. Also, there's hay rides, so if you want to live out your Gilmore Girl fantasies, ooh, I'm super excited for that. So if you want to fill out our interest form, it's right there, da.gd/pumpkins. And the ticket link is also right there. If you guys want to go ahead and purchase ahead, you can only purchase your tickets online, so you can't purchase there. So make sure that you do that and join us there. See you.
Yeah, by the way, that's Allie. She's been making really awesome graphics for us. So thanks, Allie, for all the graphics. All right, cool. One-on-one mentorship. Okay. Take it away, Megan.
Yeah, thank you. So we have the interest form for mentees open by the end of this week. So this is the last call for anyone who wants to join the mentorship program and get paired with one of our alumni to get the industry insights. So if you want to get into this program, then this is the last call. Thank you.
Speaking of alumni mentorship program, there is a paid member program, which is obviously exclusive to mentorship program, or I guess vice versa. But paid membership gives you lots of benefits. You can kind of read them on the top there. Paid membership link is down below, membership.calpluswith.org, or you can check the link in our link tree, $20 a semester or $35 a year. I think it's a pretty cool opportunity, so please consider. And I wonder how many other announcements we have. So Cybersecurity Awareness Fair is happening next Thursday, October 20th, from 10 to 2. It's going to be hosted at the BSC, which is somewhere down there, where I guess the restaurants are on campus. And we'll be doing a demo on multi-factor authentication bypasses, which is pretty cool. And there's also a job fair. So if you're looking for a job or an internship, this is a great place. This is a great place to connect with recruiters. Link is below, cpp.edu/cyberfair, also on the link tree. And for the schedule for today, this is about web apps and pretty nice skeleton graphic. But I guess I'll let Dylan, Derrick, and Jimmy to take it away from here.
All right, so we have 3 things on the agenda today. First, we're going to be covering what are web apps and some basic web fundamentals, just how stuff on the web works. After that, we're going to be going into tools and then techniques that you can essentially do with those tools. Okay, that works. Okay, so yeah, what are web applications? I'm pretty sure we're all familiar with them though. So web applications, they're the interactive web pages. They are the things you run into on the internet. Everything that's hosted on a website or accessible through a website, like online stores, some messaging stuff, emails, a lot of that stuff is done through web applications. Web applications will run on a server that hosts the applications. And so the server is the server. And for us, we are the clients. The clients have to interact with the server to gain access to these web applications. So just very basic. When it comes to doing stuff over the web, web stuff will use a protocol called HTTP, which is built off of the TCP protocol, if I recall correctly. When it comes to these HTTP requests, there are 6 main methods that they will typically use to get information from a page. That's going to send a GET request. So if I just access a URL and open it, so let's just say I go to Amazon.com or something, that's going to be me sending a GET request to that page. Another request is the POST request, which is that orange one. POST request sends data to the server where the data will get where the server will get that data and interpret it and process it. A PUT request is very similar to a POST request where you are uploading data to the server. The main difference between a POST request and a PUT request is that a PUT request will upload the resource to whatever endpoint that you're uploading on the server. And if that resource already exists on that endpoint, the PUT request will update it. Whereas the POST request will generally just, every time you feed it data, it'll process it the same way and create a new result. Then there's the delete request, which will just delete a resource on the server. There is the head request, which requests essentially just the headers, which I'll be going into after this. The headers are just a part of the HTTP request. And then options is a request that you can send to an endpoint to see what type of requests does it allow you to, or does the endpoint accept from the client. These are some HTTP response codes that are fairly common. You have the 200. A lot of people just say it's like a 200 okay, because if you request something or you send whatever request, you send a GET request, a POST or a PUT, and it works, it's going to send you a 200. If you send a request and then you get redirected to another page, that's going to be a 301. So let's just say you're trying to access an endpoint on a page, but you're not logged in, so it redirects you to the login page, and then you just got 301. Then there's also the access denied, which sometimes happens if you're not going to get redirected. That's going to be a 403. So you try to hit something that you don't have access to, it's going to say access denied. If the resource you're trying to hit isn't there, then that's going to be a 404. And if you're trying to access something or send a POST request or whatever request you're sending to, and the server kind of just dies, that's going to be a 500 server error. Something happened on their end and they probably misinterpreted the data or whatever. So here's an example POST request. Those are the headers I was talking about, all that blue stuff. And then the actual body of the request is those to the whole owner ID and recipient ID. So when you send a request in HTTP, there are going to be headers attached to it, and then you're going to actually have the body of, what you're actually sending to the endpoint. The headers sort of indicate some metadata, just some details that may include things like what type of data you're sending, where you're sending them from, your ID, things like that. So you can see, if we look at the headers, I can see I'm sending a POST request to the endpoint called purchase.php. See that my user agent, which is sort of like my browser, like what I'm using to communicate with the web server, is right there. You can see the content length is 87, and I have a cookie attached. So just a lot of random metadata. Some of it's useful, some of it's just kind of weird. So breaking this down a little further, the request line is going to be at the top. That's where it says, the whole POST purchase.php. POST is the HTTP method being used. And then, oh wow, the endpoint's not updated. Should say purchase.php. Forgot to fix that. That's the path to the page where the request was sent. It says maps, but it should be purchase.php. Then you have the host and the user agent, which are a part of the request headers. And then that green redemption.nft, that's something that's provided by the browser. And then the request body is the stuff in the yellow. That's all data provided by the client side. So every HTTP request will come with a HTTP response. The response looks pretty similar to the request. So you can see the post request went through. Now I got hit with a 200 OK. There is some metadata, my headers right there, all in blue. And then in the orange, there's the HTML, which is the response body. In this case, after I sent the post request, the server responded to me with some HTML, so probably like a page rendering.
All right, hello everyone. I'll be going over the tools for web apps. So first we have viewing the source code of a web page. This is what it would look like. It's really messy and it's kind of hard to read. But you could pull this up by pressing Control U on Firefox and F12 on Chrome. And this allows pen testers to kind of see how the web page is working, to see if there's any vulnerable practices. And also it exposes a lot of information, like all these different files that this web page is using, like browse PHP, search PHP, and a lot of images. And in this example, we also have a upload form as well at the bottom. And this could help penetration testers kind of understand the web page and kind of attack it better. Next, we have a tool called Burp Suite. Burp Suite's main purpose is to act as a proxy. If you guys don't know what a proxy is, it's basically something that gets traffic and forwards it to somewhere else. So in this case, Burp Suite is our proxy, and it sits between the client and the server. So for us, the client would be us as the user, and the server would be whatever web application you're trying to pen test. In this case, it'd be redemption.nft. It also has other functionality like changing parameters that you might not usually see as a normal user. In this example, you could see we intercepted 2 requests, 1 post and 1 GET request. And then down at the bottom, we see the raw text of the request. And at the bottom where it says username, password, and then confirm password, those are your parameters. So Burp Suite could find these parameters and you could be able to change them. This example looks vulnerable since it has the parameter account type. So account type could mean a lot of things, but one thing it could mean is the privileges that the user has. So if you're trying to register a user and you see this account type option, you might want to change it to see what happens. Next, we have word lists. So word lists are pretty self-explanatory. They're just long lists of words. There are 3 main types of word lists: password word lists, directory word lists, and virtual host and subdomain word lists. They all have their specific use cases. So each word list is specifically tailored to whatever you're using it for. So password word lists would contain common passwords or leaked passwords, and they would be used for brute forcing login pages or cracking passwords. Directory word lists would be used to enumerate website directories, as we'll see in the next slide. And they would consist of common directory names. And then virtual host and subdomain word lists consist of virtual host names. And if you don't know what a virtual host is, it's basically a way that web servers host multiple domain names under a larger domain. So an example of this could be like google.com. Virtual hosts for Google would be accounts.google.com, stuff like that, before the larger domain. But these word lists would contain subdomain names and stuff like that. So our next tool is Gobuster. Gobuster allows you to use word lists and kind of brute force a URL to see what endpoints exist on the website. So basically you would type a URL and then the word list you want to use, and then Gobuster will attempt to visit the site, and depending on which status code it gets, it would be able to tell whether the endpoint is up or it's down or whatever. So in this example, we have the Gobuster output. It found a few files like search PHP, logout.php, and it also displays the status codes. Like Dylan said before, 200 means okay, 302 is redirect, and then 403 is permission stuff. Access denied, yes, access denied. But Gobuster is a really good tool since it allows us to increase our attack surface. Since we have more files exposed on the website, we could look into them and see what possible vulnerabilities exist on these endpoints. Lastly, we have SQL Map. This is a tool that automatically checks for SQL injection vulnerabilities. We'll go over these vulnerabilities later on in the presentation, but basically SQL injection happens in fields where you search for something and it returns from a SQL database. So the injection occurs when you break out of the search query and type in your own query, and then it dumps more information than you would have had access to normally. So this is an example output of SQL Map. You could see it tests a lot of different queries, and it found the union query might be vulnerable, and this specific payload it ran to check if it was vulnerable.
So I'll be covering the techniques. This is the fun stuff. So going off what Jimmy said about the SQL map, right? So SQL injection. So pretty much this is where when an attacker is able to craft their own statement, inject their own statements into the query and have the server perform something that's not supposed to happen. So for example, here we have redemption.nft, and the function that we're looking at here is search.php, right? So it's taking our user input and we put in here just like LMAO, right? And it's going to be looking for stuff that contain LMAO. It's going to be selecting from anything that from selecting everything from listing, which is one of the tables here. And it's going to be looking for an item that contains our input. But how can we exploit this? Well, we know what the SQL statement looks like, right? So at least we can have an idea, just try to guess out what it looks like. We can start off by putting the part highlighted in green, the little single quote and a parentheses. This would end what we think might be the SQL statement, right? And we can begin our payload. So our payload in here is going to be the or 1 = 1 part. This part is understood within SQL, and this is the part that we're just gonna test to see if it actually works or not. And tac right there, which is like the stuff that's in orange. This would comment the rest of the SQL statement, because whatever we're injecting into a certain point, there might be still more to the SQL statement at the end of it. And issues can arise if we leave that there, because we might have just completely broken the statement. So we try to comment out the rest of it, and hopefully it will still read. So in this case, when we inject this statement to here, instead of just looking for stuff that just has LMAO, right? It's gonna look for also or 1 = 1, and that Boolean statement is always true, right? So instead of just looking for stuff that just contain LMAO, it's gonna dump every single item within the database. So there's just a proof of concept. There's many other ways, many other different payloads to try to get more information from the backend, but this is just one of them. So we also have local file inclusion or remote file inclusion. So LFI or RFI for short occurs when a web app insecurely loads some object, right? So again, dealing with redemption.nft, we have browse.php, and it's going to be looking for a file called sync.php. So what can we do about this? Well, instead of looking for the file that we specify, right, sync.png, excuse me, we could try to load up some other local files within the web server. So we can kind of assume that sync.png is going to be stored somewhere on the web server. And if we're able to, because sometimes websites handle user input pretty badly, like they don't sanitize the inputs, you're able to escape the directory. And if you remember from Clems's talk about Linux, you can go up a directory by doing like // to try to get up. So if we do that repeatedly over and over and over, we get to the very root file of the Linux web server. And we're thinking, okay, what files exist on here and what can we try to hit? So like a common file on a Linux system is etc password, right? So a lot of times what I would do to test this out is instead of providing sync.png, I would do // over and over and over, and then hit etc password. And if this works, it would display etc password on the page rather than an image. So RFI is kind of similar, but instead of looking for a local file, you're going to be looking for a remote file. So for example, instead of putting sync.png, you could just try to load in some other link to an image. And as a proof of concept, if that works, it will load in that image instead. For Windows systems, you would typically be providing a UNC or Universal Naming Convention. You can try to be pulling up from a network share instead. It's just multiple ways to go about this. So another common one, we have command injection. So command injection is a way for an attacker to get the web server to perform some sort of command that is not supposed to. So we have same website, but this time we're dealing with purchase.php, which is taking two parameters, right? And it's going to be passing them into some sort of command to work with. So what can we do here? Well, if you guys are familiar with commands, you can usually put like a semicolon, right? Semicolons will allow you to run two commands at once. It will run the previous one and the one after. So again, if user input is not sanitized and we're able to put a semicolon, we could try to run an extra command here. So for example here, the original request is going to be in red right there. That's like the data that the server was expecting. However, since this is being executed as some sort of command, we could put a semicolon at the end and run a different command. So in this case, for a proof of concept, we're going to be trying to ping our own machine, right? You just specify your IP instead of those X's there. And the ping would send out packets. So if you have some way to capture those packets on your own machine and see that, oh, hey, somebody actually tried to communicate with me, you know that you have this website, or at least this endpoint in particular, is susceptible to command injection. So not a very common one, but this one I think is really cool. It's called mass assignment or object injection for PHP, since we're dealing with PHP. This is where when a hacker gets to use a proxy like Burp, as Jimmy mentioned, this way we can see what we're going to send, right? And we know that the data that we're sending is being binded to some sort of variables on the back end. So we have a form data here, for example, right? This is an example from, I think it was the register part. So you got to sign up with your username, your password, your confirmed password, so you're just confirming it, your wallet ID, and a certain account type, but that type is hidden. So usually you're not supposed to see that, but when you're proxying, you get to see a lot of different things. And these values get binded to some variable on the server end, and then the server gets to do whatever they want with it. So I'm gonna turn back to the crowd. So for example, we have this post request. We see that some user has signed up with the name Bobathan, password ASDF, confirmed it with ASDF again, and wallet ID type 1234, and a certain account type right there. So what could we do with this post request to try to use this? Anybody? Oh, no one wants to answer this one. Whoa, thank you, Taylor. So yeah, account type 2. You can kind of infer at this point, like, hey, I see an account type 2, right? It's kind of odd because A, I'm trying to sign up as a user account, and B, doesn't this kind of mean that there's multiple user account types? So, well, what would happen if I send it to a 1, right? So you just pretty much intercept the request, send it to a 1, and we'll see what happens from there. It's kind of hard to verify whether or not it did anything. You'd have to find a different endpoint on the website. So for example, if we went through, if we use Gobuster and we found some site that said permission denied, right? Because you're just a typical user account at that time. So we can try visiting those endpoints and see if we actually have access to them. So for example, an admin site, right? Admin sites would typically restrict you from visiting them. But in this case, now that we have registered for an admin account, assuming that we might have done that, we should be able to visit the site now. So we also have, these ones are going to try to go over these ones really quickly. This is server-side template injection, or SSTI for short. This is where when an attacker, it's kind of similar to a command injection actually, where you're injecting a template into, you're injecting into a template into the back end of this. So for example, some common ones, we have Jinja 2, which is a Python template, and we have Twig for Java. So there's multiple ways a web app can render a page, right? There's hard-coded CSS or CSS and HTML, which would load up the page normally. But there's also a way to do it with a template. And if you have an idea of what the template is, like if it's Python or Java, and just use those respectively, you could try to inject something that's not like an object that's not supposed to be rendered. So you can look for some password field, right? Or as a proof of concept, you can do my favorite one, the 7 times 7. If you see a 49 somewhere on the page, that means, hey, it's working. And most of the times you'd be performing this in the comments, because generally comments are rendered through some sort of template. And another common one is like server-side request forgery, where again, if you don't have access to an admin page or some sort of resource, right? If you're able to see a request that a server is making and you're able to manipulate that, you can get the server to access that resource that you weren't able to. And instead, just now you can see it because you're requesting on behalf of the server. So hence why it's called server-side request forgery. And some other things that are good to know. There's also insecure access controls, which is pretty much, or access controls is pretty much just a way of saying, hey, you have access to this, but you shouldn't have access to this kind of thing. And there's multiple ways to implement this. For example, we have parameter-based access methods, which is typically stored through a cookie. So in this example here, we have user rights. Typically, these things are binded on login. So when you log into your account, the server recognizes that, oh, hey, you're a user, you have this ID, you have this and so on. And these are all stored in the cookies, right? And in this case, if we're able to view the cookie, we are able to see that admin is equal to 0. And well, if it's probably like a Boolean statement that we think, just flip that to 1 and all of a sudden you're an admin. There's also refer-based access control, where it's like, if you're on a previous site, the site kind of trusts you at that point. So any access any endpoint that you try to reach from then on is like, oh yeah, you were just on the admin site, so I'm assuming you're an admin, but maybe you might not have, and you just got access to that site some other way. But that's another poor security method thing. There's also insecure direct object reference, which is IDOR for short. This happens when a server is loading in objects kind of insecurely. Like in this example, we have something called, or the website, right? It's looking for listing ID 0. So that's one of the objects that it's pulling up. But what would happen if we put listing ID equals 1 or 2, 3, and so on, right? You're going to be loading in different kinds of items that it's trying to list. And that's generally not safe, because what if you have something that you don't want to be displayed right there? I mean, you can kind of just brute force and guess your way through. So yeah, that's pretty much it. Yeah, that's all. Any questions? Yeah.
So just like a quick TLDR, this is like a lot of different things on web applications. I think the slides are on the link tree, so you can reference them there. But I understand this can seem pretty complex. Like there's a lot of like web application stuff and SQL injection stuff. It takes time and practice to like get used to web applications, and like the more experience you have, the better it is for you to like see where you might be able to try some of these things. So not all these techniques are going to work on like all web applications, but like the more experience you have with web apps, the more you understand them, the more you understand what's going on and like the back end, the front end, all of that, the better idea you have on like what sort of different things to try. So I think it's a lot of like experimentation and like trying all of these things out, aka fuzzing, web application fuzzing. But yeah, this might seem pretty complex, but it does take like, experience to get used to how these things work. And at the end of the day, it's all about like understanding how a web application works, and then figuring out like what things you can do to bypass some of the controls, or see if there's any holes in the web applications. You'll be able to kind of practice all of those in the workshop on Friday. I think many of these, or think all of these, I have no idea, most of them are going to be on the workshop, so really good opportunity to like kind of try these out and see how it works and then like learn from there. But yeah, any questions on any of these topics? I know it's a lot, so feel free to ask. Okay, well, I have a question for you, Derrick. What resources would you recommend to learn more about web application stuff?
Web app stuff. Are you trying to get me to say track?
You can.
Well, I actually haven't used TrackMe that often, really. I kind of tossed myself into the fire. I just started doing Hack the Box immediately. I suffered because of it because I spent so many hours just staring at a page, not knowing what to do. But eventually I got the hang of it. I don't recommend that path to everybody because why would you want to stare at your screen for 12 hours? But I did, so. I kind of just got more experience after the different kinds of websites that I saw on the website, on Hack the Box. There's so many different environments, right? So the more you see, the more you know, and it's just, you kind of get the hang of it after a while.
There's also this online resource by the creators of Burp Suite. There's the Portswigger Academy. Portswigger Academy created by that's like the company that created Burp Suite. They do a lot of online web training. It's all free. They go over a bunch of theory and they have hands-on labs where you can test all of that stuff we were talking about if you want to try to get a hang of it and get more in depth into each of those web application vectors. If you're just more interested in just reading about web application vulnerabilities, stuff like that, there is a organization called OWASP, or Open Web Application Security something, or project. And they do a lot, they talk a lot about web security. I mean, it's kind of in their name. But if you really want to do like the hands-on web exclusively stuff, then definitely take a look at Portswigger. It's completely free and very informational, very in-depth.
Speaking of OWASP, I don't know if OWASP had made this, but there's a vulnerable web application or various of them. I think there's one called OWASP Juice Shop, which is kind of like a vulnerable website that you can go onto and then try out a lot of these attacks. I have no idea where it is. I think it might be this one. Yeah. So like if you want to kind of just practice some web application pen testing concepts, this is a pretty nice place to try it out. I think there's also I think it's this one, Damn Vulnerable Web App.
Oh, I've not heard of that one.
Yeah, so this is like another resource you can use that contains a lot of web application vulnerabilities. I think this is something that you have to set up on like your own home lab or VM, but this does have a lot of good information as well. So yeah, if you want to practice more on your own time on like web application stuff and like learn on your own time, these are two really good resources, plus the ones that Derrick and Dylan have mentioned previously. Is there anything else you want to mention? Okay, so I think that's it for the general meeting. We're gonna have a workshop on Friday with a lot of these things. I think there's an interest form on Linktree. So if you're interested in the workshop, please fill that out. Once again, sign-in link is also on the Linktree. I guess everything's on the Linktree at this point. So if you haven't signed in, please sign in. But with that being said, have a great rest of your day, and I hope to see you on Friday.